Good afternoon. Thanks for coming out today. It's always nice to get outside and see an active construction project and really make some of these budgetary discussions, we can actually make them into reality. Today I just want to kind of unpack the team that's involved with this project, and ultimately then we've got Ryan Johnson and Dustin Poston will take you through more of the details specific to this project. When the City of Sioux Falls embarked on sourcing the right team, we brought in they're a global consulting firm, HDR. They have a large presence here in Sioux Falls. And so we've got a really good design team that's taken us through all the various options and ultimately to final plans, bidding, and have a successful contractor on board getting this work underway. We have a great contracting team, H&W Contracting. They're a local firm. They do a lot of large diameter, deep pipe, and so it's always good when we see a strong contractor get these projects, but also it's a double benefit when they're a local contractor. They don't have to travel, makes it a more advantageous project for them. They also source a lot of local suppliers for their product. The materials that have been spec'd are the best products you can buy today to stand up to the corrosive nature of wastewater. This product you'll hear more about. It is made in the USA. It was ultimately invented in Europe about 50 years ago. Some of those initial installations are still in service. That was one of the drivers for us to continually source this product. And then really then locally what takes these projects from concept through budgeting to ultimately construction, you have to have a strong internal team. We've got two real sharp professional engineers that have laid these out. The first one you're going to hear is Ryan Johnson. He's the principal wastewater engineer for the City of Sioux Falls, manages all these, identifies and manages all these large projects. Ryan's going to give you some perspective of how we got here, why we're doing this project, and then ultimately we'll turn it over to Dustin Poston. Dustin's the detail guy on this project, another strong engineer that manages everything from project costs, daily reports, answers hundreds of questions on a weekly basis for the contractors to make sure we can continue to progress forward. So first we'll bring Ryan Johnson, and he'll give you some perspective on why we're doing this project. Ryan?
Thank you all for coming out this afternoon. This is certainly an opportunity that we enjoy to highlight what we're up to with our Water Reclamation Division and show people what the ratepayers are paying for when they write their monthly water and sewer bills, and how we're taking those funds and using them to constantly treat wastewater that's coming at us, providing a high level of customer service, and ultimately protecting the water quality inside the Big Sioux River and our aquifers. Story kind of begins with the replacement projects in 2010, when a large diameter sewer about 2 miles west of here collapsed. That sewer was made with a similar type pipe that's being replaced today. It handled about a third of the wastewater that was generated in the City of Sioux Falls. That sewer, along with several other large diameter sewers, enter into the sewer that's being replaced, which currently serves about 90% of the wastewater that's contributed to the City of Sioux Falls. That pipe is a 66-inch diameter concrete pipe. It was certainly made with the best available materials, and at the time, it's reached its useful life, and we're trying to be proactive about replacing that infrastructure in a timely fashion to avoid incidences like the one that happened in 2010. Just a little more background on what we do as a division. We have over 800 miles of sanitary sewer in the ground. To put that in perspective, that's about a distance from here to Dallas, Texas, a little less than 800 miles. And we're charged with providing reliable service. We're trying to keep all that wastewater inside those pipes, and we're trying to avoid any of that coming outside of the pipe. We also treat at the water reclamation facility about 2 miles northeast of here, about 6 billion gallons annually That's a little over 16 million gallons a year, and it goes through several very finite processes that are highly regulated and highly managed to ultimately discharge that wastewater in a very satisfactory manner for our permit and for us as a community in general. So just like your roof at home and the tires on your car, that infrastructure wears out and it needs to be replaced in a timely fashion. So each year we budget and we appropriate to make sure that those replacements are happening. And so in the next 5 years, we're anticipating spending over $116 million on those 800 miles worth of sanitary sewer mains and gravity sewers and lift stations, along with our water reclamation facility that treats anywhere from 13 to 30 million gallons per day. So with that, I'll hand it off to Dustin to take you through a little more details on the project.
As Mark mentioned, my name is Dustin Post and I'm the city's project manager for the outfall sewer replacement project behind us. I'll just be walking through some details of the project, technical aspects, then at the end we'd be happy to answer any questions you guys have. The project is designed by HDR Engineering, their Sioux Falls office here in town. In May, a contract was awarded to H&W Contracting for $13.4 million to complete this work. The anticipated completion date is September 2017. Approximately 9,700 feet of 72-inch gravity sewer pipe will be installed with this project. The project limits begin west of Cliff Avenue at the equalization basins and continue here to the city's main pump station, the Brandon Road Pump Station. And as you can see, it's continued, it's began here and it's proceeding to the west. The pipe selected for this project is Hobos pipe, as Mark mentioned. It's a FRPM product, which is a fiberglass reinforced polymer mortar pipe. It's state-of-the-art pipe. It's highly resistant to the corrosive wastewater environment, and it's an incredibly smooth pipe, so you get great capacity improvements through the pipe. Ryan had mentioned that the existing pipe is a 66-inch pipe that was constructed late 70s, early 80s. Best product at the time, but it's a concrete pipe. It started to degrade, and so by increasing the pipe from a 66-inch pipe to the currently being installed 72-inch pipe, you provide an additional 21 million gallons per day of capacity just by increasing the pipe those 6 inches. In general, the pipe will be installed using standard open cut trenching methods. The exception is at the Cliff Avenue crossing and the Interstate 229 crossings, where we'll be utilizing trenchless or tunneling methods to minimize traffic disruption at those key streets. The crossing at Cliff Avenue is approximately 150 feet long. The crossing at Interstate 229 is approximately 350 feet long. Beyond the actual installation of the 72-inch pipe, there's other improvements being made. There'll be a new small pump station installed at the intersection of Cliff Avenue and Walnut Street. There'll be approximately 700 feet of 36-inch HDPE siphon pipe installed across the Big Sioux River, with improvements made on both sides of the river to the siphon box structures. The work will be installed during the winter months due to the impacts to the temporary levee. Due to the temporary impacts to the city's levee system of the Big Sioux River. Also, there'll be approximately 900 feet of 36-inch PVC pipe installed from the equalization basin diversion structure to the equalization basins. That pipe will be a parallel 36-inch pipe to the existing 36-inch pipe to provide greater capacity. It'll also provide more operational flexibility for the city during high flow events. That's typically during high rainfall events. In addition to that, there'll be structural modifications and additional gates and flow meters associated with that equalization diversion. Overall, the project's anticipated to take 16 months to construct, and there'll be over 50 acres of restoration required with the project.